All right, welcome everybody to a third video in this series of the development log of this little game that I'm working on, Jerboa Wars. We'll pick up where we've left off. Last time we started working on our JSON component. This component is the root of the graphics engine for this game. So we've started building the basic mechanism for drawing sprites, and today we will build on it and expand and build a new component, which is a grid sprite. Now, let's see what it is, how it works in the context of this application. Let's look. So first of all, as we're using SpawnDev's Blazor.js Pixie.js wrapper for the Pixie JavaScript library, as I mentioned in the first video, actually, it looks like SpawnDev is still working on this on his wrapper, because a lot of the stuff that is in the JavaScript library is missing from the wrapper. But no worries, we can easily add and extend the functionality that's missing. Just build it ourselves. That's the beauty of open source. All right. Now, the component that we're going to add is a sprite grid, and a grid sprite. We'll talk about that later. So the idea is, so as a texture allows us to draw a single sprite on the screen, a sprite grid is an abstraction of a collection of textures, actually texture objects that under the hood still have only one physical texture asset. But the idea is that from a single texture asset, we could create multiple in-memory textures that is a subset of frames from within this one texture asset, and then assign that to a special sprite that can have these frames drawn in one instance instead of having multiple sprites. Anyway, and we are going to add that extended grid sprite, which inherits from the JSprite and has access to this multiple texture asset, as opposed to when the JSprite only has access to one single texture asset. Okay, and we are going to build a little test page in the same. We'll continue building on the same test application that we've started last time, and see how all of this works. All right. So let's look back again at our architecture for, or I'd say inheritance diagram for our iScene object interface and JScene element abstract class, as you remember from last time. What we are going to be looking at today is the JGrid sprite, what we'll be actually building today. And that is as you can see, it inherits from the JSprite. So it has all of the properties and methods and everything, whatever. It just adds the ability of this sprite to leverage a sprite grid as opposed to just single texture. So what is a grid sprite then? A grid sprite, as you can see, would have a texture like this, which is a single image that contains a subset of frames. And actually in Pixie.js library, there is already a class that can deal with this sort of scenarios. Is called the sprite sheet, which is slightly different than the grid sprite. And the difference is like not that much, but we'll talk about it in a bit. But the idea is the same. So there is one texture asset, and that texture asset contains a subset of regions that can be mapped as frames. And then what Pixie.js does, it generates a in-memory texture just for those regions, texture objects. And then you could have a sprite, or they have the animated sprite actually class that can take a collection, an array of these in-memory textures, and show them in sequence, or however you like. You can just index them by their index. So, but grid sprite, what we have is a similar concept, only kind of extends it to a two-dimensional array rather than a single-dimensional array. And it also makes it, because sprite sheet has the ability to map regions from a texture that are different size, different positions, not like in a grid like this. There is a JSON metadata associated with the sprite sheet that is used to map all of these frames. And it is a very versatile, very flexible setup, the way it is done in Pixie.js. However, it does require a little bit more metadata tracking. So you have to have this information about the position and size and all of this stuff for each single frame mapped in this JSON input. So what we have here is actually by having sprites organized into, I would say, textures organized into a grid like this, where each frame is exactly the same size, and they are organized in a table of rows and columns. The only 4 data points that you need would be the size, x and y, height and width of your frame, and then number of columns and number of rows. And that's all you need to load this grid sprite. There's no JSON metadata associated with it or anything like that. So it's a little bit more, it's a little easier to manage in that sense. However, the compromise, of course, is that in memory, in principle, it is a lot less efficient than sprite sheets, because there you can pack your sprites a lot tighter. Here, as you can see, for example, in the 3rd row, or in the row index 2, only the first frame is used, and then the 3 frames are empty. And if we're not using those are still in the grid sprite are created in memory anyway. So, but it's, again, because the game is not heavy or anything like that, I'm not worrying about, it's not going to be very heavy on CPU, GPU, or on your memory. It's not an issue here. It's just easier to deal with. There are additional benefits that you can get from having the sprite organized, the sprite collection, let's say, organized in grids and columns and rows, and we'll get to it. All right. Now, what we need to build for this. The first thing we need is a sprite grid asset loader, and that is the abstraction that takes a texture, a Pixie texture, an object that a class that we defined last time, and actually creates a sprite grid asset in memory. So what it does, actually, I was talking about the sprite sheets. We are going to leverage the Pixie.js sprite sheet to do that, to actually load the texture and define the frames and load them separate them into small textures. So 1 texture per frame. We're still going to do that with the sprite sheet, but the thing with sprite sheet is that it does need the metadata for it, as I said, and the metadata will be generated automatically on the sprite creation with only those 4 data points that I was talking about in the last slide. So another thing that is a little bit of an obstacle is that the sprite sheet wrapper is not at this time in the SwanDev's library. So, but again, we are just going to extend it ourselves. And it's not that much work, as it turns out to be. So let's do that. And we are going to also, because the sprite sheet metadata has to be communicated to the sprite sheet object on the JavaScript site, we need to make the sprite sheet metadata properly serializable for the Pixie.js to correctly read it and use it. So we'll see how that is done. And that will require another class that we'll need to wrap for Pixie.js that is not in, it seems, unless I missed it, in the SwanDev's library, which is the texture dictionary, or I don't know what's actually called on the JS side, but that actually is a very, very shallow wrapper. For that, it's a keyed collection of textures, pretty much. You'll see it's we only need 1 method from that class. And finally, we will add some methods to our asset builder that will, well, actually we'll add 1 method and we'll add code to the build method itself to take care of building the sprite sheets. All right, so Sprite grids, I should say. All right, so I was talking about Sprite grid, and then I was also talking about the grid sprites. So what is the difference? Just so people don't get confused, maybe I should have named it better, but don't expect too much from me in that regard. But the idea is this: the Sprite grid and the texture, they are the static assets. It's think about it something like a image file that you load at the application initialization time, and that file is then parsed and stored in memory during runtime. That has static information about the images and the frames and things like that. But the grid sprite, which is represented by class JGridSprite, is the same as JSprite. Those are the actual dynamic view objects that are then used to draw the content of textures and sprite grids on the screen. And that is something that those dynamic objects that are like created, destroyed, moved, changed all the time. That is the actual, think of it as an actual view that is representing, that feeds on the static assets like sprite grids. So that's about it. So there's not much more that needs to be said here. So let's go to our Visual Studio Code and see what's what. All right, so we are here in our project, and actually instead of building it and talking about it at the same time, I thought it would be faster if I could I would build it off screen and just show you what has been done. And remember, all of this is in a public repository in GitHub. The link in the description, and you can just clone that repo or download the files if you'd like, and try and compile and run it yourselves and figure out what's going on. But I will just go through all of the stuff that has been added since last time, and that is related to what I was talking about in the presentation about grid sprites and sprite grids. All right, so the first thing that is new here is the Pixie extension folder here, and there are a number of classes there. All right. So here we are in the Pixie.js API, which is a very useful, very neat and useful document about everything that is there for a very useful document with everything that we need or anybody would need from Pixie.js. And let's see. The idea is that, as I mentioned earlier, there are a few things that are missing that we need wrapped from this FontDevs library, and one of them is the Spritesheet object class, Spritesheet class. So the Spritesheet, this is a wrapper for the JavaScript object of the same type in Pixie.js. So if we go to the API and we look for Spritesheet here, you can see all of the members and methods and all of that for that class, and simple explanation of how it works. So you can see this is the metadata that I was talking about in JSON format, where you have an image in your metadata, which is a URL to the actual image file, usually. And on top of that, you have a dictionary of frames. For every frame, you can specify the location, the location in the source texture, the size, the source size, and all of this stuff. I'm going to go through this. You can read it. It's pretty straightforward stuff. You can look at the examples. Where is it? I guess. Sprite. Yeah, I think we've looked at it before. So this is the jet plain example that they have there at the Pixie.js website. So, but we don't need any of that all we need, we actually just need the sprite sheet reference, because all we need is just one method pretty much from this object. So as you can see, for example, you go to the API, there are a lot of other things. You have all this different properties and stuff that we could wrap as well, but at this time we don't really need them. The only method we really need is this one, is parse method, the very last one here. And what it does, it does accept, I think we have here as an example for that. When we are creating the new sprite sheet, we supply in the texture, that is the main texture with all of the frames, as well as the JSON metadata, like something like this. And then we call the async method parse, and this is what actually takes this texture, and then for each frame generates an in-memory texture objects that are mapped to the original texture as well. So this is that is all done on the JavaScript side by Pixie.js. Automatically, we don't need to worry about that. What we need, we just need to call this method on the JavaScript side, and that is what we do here. We wrap this method by into the sprite sheet reference, where we instantiating the sprite sheet with the same parameters, the same arguments as in the JavaScript. We have the texture argument, and then we have the sprite sheet data. And then once we have that, see, it follows this constructor the same way. And after that, we have this parse method, which is also asynchronous. It calls the async method into JavaScript with the name parse, and we don't need any arguments for it. As you can see, it's just a function with no arguments. It returns the texture dictionary object, which we also define here as well. Has only one method, is get the texture by name, and that is also calling into the JavaScript reference side and gets the texture this way. All right, hope this makes sense. Where are we? Okay, so this is all pretty straightforward. Once again, as you can see, this class is inheriting from the JS object class, which is SpawnDev's base class for a JavaScript object reference. Accepts the in-process object reference pointer, you could say, to a JavaScript object and things like that. It's very, very straightforward, very nice, very nicely done. All of this stuff is hidden behind the scenes in this SpawnDev's nice JavaScript interop library. So all we have to do is just call the GS, which is the JavaScript runtime. That is a property of the JS or whatever the one of the base classes, and this method new creates a new instance of the Pixie sprite sheet in JavaScript with these arguments, and the texture argument is the same class that we have. That is actually the class that SpawnDev's library wraps from Pixie.js. But the second parameter is sprite sheet data. That is something that was not, at least I didn't see at the time of making this video. This class has not been added to the SpawnDev's library. So this is what we have here. We have to create it ourselves. And this class is just, it represents the JSON metadata for the sprite sheet. It does not really have any functionality in it. It's just a data structure pretty much. So it's very straightforward to implement. As you can see, we just need to find what the class is on the Pixie.js side and reproduce it on the in C#. Okay, so here it is. So this is the structure of the sprite sheet data interface. I guess that's what it's called here. So what we need is the frames dictionary and some of the metadata here. We need to reproduce this if we want to pass this parameter in our C# code. We need a data structure like this, or at least partially implementing the stuff that we need from it and pass it over to JavaScript side serialized as JSON. So let's see how that is done. And it's, again, pretty straightforward procedure where you just follow whatever the names and the types and everything in this interface and reproduce it in classes on the C# side. So let's see. For example, we have the sprite sheet data, and I have a sprite sheet data class here. And all we need to do is make sure that it is serialized into JSON the same way as Pixie.js expects it to be serialized. So for example, we have the animations property here, which is a dictionary of strings. And the animation, it says the animation of the atlas, whatever. So it's a dictionary, actually not of strings, it's a dictionary of string arrays. So we may have multiple animations, and each animation is an array of strings that represents the names of the frames from the frames data. And this is what we have here. We have the dictionary of animation. Well, we are not going to be using actually it anyway. This should be an array. So as you can see, it says 0 references. It will not be used because we do our own animations. I just have it here as a placeholder for now. If we need it, we can change it later. So that actually has to be an array, not just a string. But what we do need is the frames. And as the second parameter here, second property, I would say. And that is a dictionary of the sprite sheet frame data. And this is what we have here. We have a dictionary that is indexed by the string, which is the name of the frame, and then we have the object represented by this sprite sheet frame data. And what I want to just emphasize here is how we decorate these fields to make them appear in our JSON serialized string that is passed over to the JavaScript correctly. So we can name the properties actually whatever we want. It's good to have them named the same, but we can set the property named on the JavaScript side. On the JSON side, including the case of the letters has to match exactly how it is defined in Pixie.js. Otherwise, it won't work. The same way, we have the metadata here under the meta. And we have our class, which is the sprite sheet meta, which is the same. Well, it just represents like this stuff, not everything, but again, we have to map the properties that we need in that class the same way and just nest it within our sprite sheet data. So let's look at, for example, the sprite sheet frame data. Here you can see here the same way we can navigate to the definition for the sprite sheet frame data. That is a class that represents the data for a single frame. I don't know if it's a class, it's probably just an well, anyway. And as you can see, it's pretty straightforward. We have the point data, we have the texture borders, the frame itself with very simple X, Y, W, H, things like that. And again, we don't even need most, even though we implement it, I follow the properties closely the same way. Some of them we won't be using. And, this is a mistake. Here, for example, this should be small t, trimmed. And once again, because I've never used it anywhere, that I didn't have a chance to find this bug. All right, now, and that's pretty much it. That's the whole idea. It is a little bit tedious because there are a few of these things, objects that we need to, classes that we need to port basically from how they are defined in Pixie.js into C#. But once we have our definition of the class, the sprite sheet data, that can be used directly as a, because we define the serialization parameters and everything, it can be used directly as an argument when calling into JavaScript using SponDev's Blazor.js interop. And that's about it. Okay, this is all we need to add the stuff about the sprite sheet that is currently missing from SponDev's library, and use that to make our sprite grid. And this is the class that we have here. Remember, the sprite grid is this static asset that leverages the texture asset to generate the grid of frames and calls into Pixel.js. It has the sprite sheet under the hood to manage these frames and create those textures for each frames. But that's about it. That's what we needed the sprite sheet for. We don't actually use the sprite sheet. The sprite grid just uses it to initialize the sprite grid, and that was that was about that. That's all it's used for, really. And then once we have the sprite grid, we can use the grid sprite to have to draw the frames from this asset onto the screen the same way a sprite draws texture on the screen. So let's see what we have here in the sprite grid. And the advantage is, again, that the metadata for the sprite grid is a lot simpler than for the sprite sheet, and we need to worry and manage about it. Since we are in control over making our own textures and how we organize the sprites on these textures, we just put it on the texture in a way that are organized in grids, and then we don't need to worry about the metadata as much. All right, and here what we have like I said, there are only there are 4 values that we need to define a sprite grid, really, as far as metadata is concerned. And that's the number of rows, and then the number of columns. So these are the 2 properties. And then we need the size data, which is a vector type kind of class that has the width and the height defined as float values, because the columns and rows are integer, as you can see, and these are the floats where we have the width and the height of the frame. And since all the frames are the same, these are the 4 values that we need. One other thing we optionally need is, depending of where that sprite grid located on the texture itself. If, for example, you have a sprite grid embedded with a larger texture, then the location property tells it where to start looking for the grid. So you could put a location for the entire grid on inside the texture, and then within that, it will use the number of rows, columns, and the sprite size to map out the actual frames that will be used by this sprite grid. All right, and we have one source texture, as you can see, and then we have the list of textures which are frames. And these are empty before the sprite grid is parsed. And we have a method here that says parse from the source texture, and this is what's going on here. I'm not going to get too deep into this. I mean, there's not a lot. You can look at it if you want. But the idea actually is to take the source texture and build the sprite sheet out of it. And I have the method here that generates based on the data points that I was talking about, like the frames and the rows, columns, and the sprite size and all of that. It dynamically builds this JSON metadata for the sprite sheet that is then passed over to JavaScript when the sprite sheet is parsed. And this way, we get the sprite sheet with all of the textures, and then what we do, we just go through the frames of that sprite sheet and put them, these textures that the sprite sheet generated, the references to those textures, we put them, associate them with the sprite grid based on the row and the column. And that's it. So it's kind of like a little bit higher level wrapper around the sprite sheet. That's what sprite grid is, with a little bit more constraints on it, but a lot less management. All of this is automatic. Right. So this is what we have. We have the extensions, we have the sprite grid, and now what we need, 2 other things. We need the actual grid sprite now. That is the entity, the dynamic entity that will be using the sprite grid asset, the sprite grid asset, right, to draw frames based on whatever the frame index is, right, the row or column. And as you can see, it inherits from JSprite, just as we showed in our diagram in the presentation. It has a source grid reference, which is has to be passed to the JGrid sprite at construction time. As you can see, one of the arguments in both of the with both of the constructors, the sprite grid argument has to be there because the grid sprite needs to know which sprite grid is going to be using, and that's about it. And then we have some methods to set the frames, either by row or column or by the just one frame index. And there's a little bit of management there. There will be a little bit more later. We'll be adding to it and as to other things, but for now, this is all we need. So that's one thing. And the last thing that we need a builder routines. We need a method in our builder service, which is here. We have the JSON builder to add the asset actually to the collection on the JSON. All right, so in the JSON builder here, we're just adding this method. We already had the builder methods. If you remember, for the scene, we have the start scene, we have the add texture. So the third one we've added is the add sprite grid. We give the name, we give the texture URI to the same texture that's been loaded before. And we are giving the opportunity for the user to map out the metadata for the sprite grid. Remember the rows, the columns, the size of the frame and things like that. I mean, those are the only things really. So whenever on the consumer side this method is called, there's a callback that can be made to set up all of these properties on the sprite grid. All right, and then that all is memoizing all of the information about the assets that need to be built. And then when we call the build method, that is when the actual parsing of the sprite sheets is happening. This is this wrapper that we wrote that does the parsing. As you can see, the sprite grid parses the texture and generates the metadata for the sprite sheets and things like that. And once that is done, then we are adding the sprite grid with parsed texture information, with parsed frames, with all of the stuff loaded in memory already, all the data loaded in memory, that is added to the scene, just to that dictionary that I showed you earlier on the JScene object. And we have that accessible by our render tree. All right. And I think that's about it. So now what we're going to do, we're going to run a little test on this and see how that is implemented, how we can use this sprite grid and what is the benefit. Here I have we had a sprite test. I've added a grid sprite test page. I've also cleaned up a little bit from last time. Here, as you can see, made it even less cluttered, where we have now a single component that represents the Jerboa scene tester that wraps the Jerboa scene and all of the stuff behind in a component. And all we have is really on a page, on a given page, we don't have any noise whatsoever. We only have one component that has the title of the test and the two handlers for the scene build and scene initialized event. And that's all we do. So this is the example from last time. You can see that only like really 3 lines of code there that do any work. I've also added an extension to whenever the element is made, it just centers them on the screen and then scales it by whatever the scale factor is here in the argument. So I just like reusability. And this is our grid sprite test. We'll run it in a sec, but it's the same thing. We really have here, all we really have here are the two methods that build the assets, and the second method is building the our render tree. So you can think of it as this is the static asset builder, and this is the dynamic scene builder. So as before, we have a texture. Actually, we're going to use this texture, the one that I showed in the presentation for the tiles, as our sprite grid. But first, before we use it as a sprite grid, we need to load it as a texture. So we are adding the texture to the builder with this URL. And then after that is done, we can then add a sprite grid using this texture from with the same name. We give it the sprite grid name is going to be just tiles, and then this is the Lambda action that is called when this sprite grid is built, and all we do here, we supply the metadata. So you see, instead of having this lengthy whatever JSON file like this with all of the stuff in it, and we only have just a few lines to define the sprite size and the number of rows and number of columns. And that's it. And we have our sprite grid with this name. It's added to the scene dictionary, and we can use it then when we are initializing the scene with the render tree. We're just adding this JGrid sprite instance. As you can see, the arguments is we're putting at the root of the render tree. As a parent is the render tree, and the second argument is the sprite grid we get from the dictionary, from the scene based on the name, which is tiles, and then this is the name of the sprite itself, which can be anything, like as long as it's unique within its branch. And then now we have this grid sprite, the same as sprite. It has, because it inherits from Sprite, it actually implements the scene object interface. So it has all of these properties about the position, location, translation, whatever, scale. So we can use the same extension, because this extension is for the scene object. Only instead of scaling by 3 as the bunny sprite, this one we're going to do scale by 2 because it's a little bigger. So what else? What I've added extra? So this is as far as loading the asset and the sprite grid asset, and then displaying it on the scene, the static thing. But now I also added a few things here to show what it looks like if we just dynamically change the index for the row or the column. So you can see that we can manipulate the frames dynamically from our application or from user actions or whatever. In this case, what I did, I've just added two little range input components, and one is manipulating the rows, the row index, and the other one is manipulating the column index. And I bound these values to these properties here. Not here. The value is these properties, row and column, that are actually calling the method setFrame on the tile sprite grid, JSprite grid. As you can see here, we have the reference to the JSprite grid, which is set here, and then on that we just call the method to set the row and the column. Depending on what value is set, it just calls that method. And what this does, it then calls into JavaScript and does all of those things behind the scenes to change the frame. And one other thing it does is that I set the max range from the tile itself, from the sprite grid itself, based on the rows and columns. Only it needs to be 0 based, so it needs to be less than the number of rows and columns. Anyway, so that's about it. Let's run this and see how it all works. Right, so we have test 1, now we have the test 2. That is our grid sprite, and there it is. So this is the tile loaded from that texture, and if we are changing the column, we can set the column. As you can see, it changes dynamically, or we can set the row. Only 2 rows actually I set, because the third one is empty pretty much. And if we change the column, you can see that all of that, our sprite reacts to these inputs, to changing these properties, or rather, it's just it calls the method on this JGrid sprite to set the frame, and we don't need to do anything else. So our procedures in the game, if we want to make an animation, all we have to do is just map the animation onto this onto these values, and that's it. So that's Sprite Grid. All right, thanks for watching, and I'll see you all next time.